let's do problem 37 on page 163 of chapter 6. Here's the problem. Number 37. It's right here. Zoom in so you can see it. It says, a 65 kilogram trampoline artist jumps vertically upward from the top of a platform with a speed of 5 meters per second. Okay, how fast is he going as he lands on the trampoline 3 meters below? If the trampoline behaves like a spring with a spring stiffness constant of 6.2 times 10 to the 4 newtons per meter, how far does he depress it? I think that last part B is tricky. All right, but let's try to do it. So I drew it up here. Okay. So here's the person. They're standing at the top. They jump up. They're going 5 meters per second. Then they land right here. Now they're still moving, and then they come to rest right here, and we'll see how far they stretch that material. So let's solve it. And this is an energy problem. And when I look at a problem, I say, okay, is this an energy problem? Look what's happening. Somebody's jumping up. They have kinetic energy. They have they did give the mass of the person, didn't they? I didn't write it down. 65 kilograms. Okay. And now you don't need that to figure out the velocity, but you will need it to figure out the stretch of the trampoline spring. Shh. Okay, so for part A, we want to know when they're right here. Okay, the person is right here and they're falling down, and we want to know what is the velocity right here. Well, I'm going to use energy to do it. You could use kinematics to do it, but I'm going to use energy to do it. Energy is actually a little bit easier. E initial equals E final. Now, where do we want to measure gravitational potential energy from? Well, I'm going to measure it from right here. Okay, from right here. And I'm going to say, so the initial energy, this person is 3 meters up, so they have gravitational potential energy, and they just jumped, so they have kinetic energy. So they have initial kinetic energy plus the initial gravitational potential energy is going to equal their final energy. Now, if I say U equals 0, that is the potential energy is 0 right here at the top of the trampoline. Okay, that means they don't have any gravitational potential energy anymore. It's 0. But they do have kinetic energy, and that's going to be K final. This law of conservation of energy now gives me an equation that I can use to solve the problem. 1/2 mv initial squared plus mgh equals 1/2 mv final squared. Okay. So in other words, here's where my initial mechanical energy was. Here's where I'm planning. Now, and look, there's no friction in this problem. And there's no outside force, adding energy to the problem once the person has jumped up. The only forces doing work here are gravity and springs. Thus, this is a conservation of mechanical energy problem. And thus, you start off by saying E initial equals E final. And notice that I don't need the mass, so that goes away. And I'm just going to solve for V final. So V final is equal to 2 times all of it. Well, let's multiply everything by 2. Gets rid of that and puts a 2 right there. And now I can just take the square root of V initial squared plus 2gh. Now I can plug in my values. The initial velocity is 5 meters per second. plus 2 times 9.8 meters per second squared times h, which is 3 meters. When I originally did this, I said, okay, they fell down 3 meters, but since I decided to make u equals 0 right here, their initial gravitational potential energy, well, that height is 3 meters up, not -3. So now I get out my calculator, because I can't do that in my head. Okay, 25, that's 25, plus 2 times 9.8 times 3 equals, that's 83.8. Raise that to the power of 0.5, that's a square root, and I get 9.15. meters per second. Then, because I'm a good student, I look it up in the book, because the answer's in the back for the number 37. And it is indeed, oh, they say 9.2 meters per second, and I put 9.15, so yeah, they rounded it off a little more than I did. So that's good. I'm going to declare that a victory. And I'm going to put a star next to it. And that makes me happy. All right. So now delta x. Now this is a little bit tricky because what we're going to do is we're going to say that the energy, well, we'll start with the initial energy here is equal to the final energy here. And well, could we do it? We could do it that way. Or I could say the energy here equals the energy here. Maybe I'll do it that way. So I'm going to say the energy here, energy initial equals energy final. Well, actually, what I could, I'll just use the energy up here. The initial energy equals, now the final energy will be down here. So this was 1/2 mv initial squared plus mgh. Now, what is E final going to be? Well, E final is going to be down here a ways. So we've now compressed the spring. So that's going to be that's going to be elastic potential energy, right? 1/2 k x squared. And they gave us k, so we know k, and we were trying to find x. But also, we're now below the reference. As we go down, as we compress that trampoline down, we've also lost some potential energy. So that's going to be mg x, and here x is going to be down. So, and this is going to be negative energy. So, okay, thank you. So let's figure out what this is. 1/2 times 65 kilograms times the initial velocity, 5 meters per second squared, plus this is going to be 65 kilograms. And then this is 9.8 newtons per meter. This is h, which is 3.0 meters. So how much energy is that?
Isn't it g meters per second squared?
What is it?
Isn't g meters per second squared? Instead of newtons per meter?
Oh, yes. newtons. This should be newtons per kilogram. Well, meters per second squared is right. Yeah, thank you. Thank you. And so let's see where this gets us. So 0.5 times 65 times 25 equals, so that's 812.5. 812.5 joules. Okay, plus 65. 9.8 plus 3, wait, times 3. So I get a total energy of 2,723.5 joules. I don't need it. I can round it off later. Okay, so that's how many joules we got. Now, this value here, this mgx, is below my reference. So I'm going to call that negative. It's going to be a negative x. And so I've got a quadratic formula. What is 1/2 k? 1/2 k is the 6.2 times 10 to the 4 divided by 2. So 2,723.5 joules is equal to maybe okay. Here's where I'm getting confused. Should I make this negative or just keep it positive and I'll get a negative x? And I think I'll just keep it positive and see what happens. So what is 1/2 k? And I'm running out of time, so I'm just going to take the 6.2, that's 3.1, times 10 to the 4 newtons per meter. And then this is times x squared. Plus, and then we have mg, so that's going to be 65 times 9.8 equals 637x equals this. Now I'm going to put it in standard form. Am I still on screen? Plus minus 2,723.5 joules equals 0. So what do we have to do with this? Did anybody do this?
I did not know how to do that.
Well, what do you call it? Something that has an x squared and an x and then a thing and then equals 0.
No, it's
You got to use the quadratic formula. Or you can, hey, you people with your fancy pants calculators, right? Now, how much time do I got? Well, so solve this quadratic. Here's a hint. If you're at home or something and you're watching this, or you went, get a Google quadratic formula, and you will find a little online app that will allow you to type this in, and this, and out will come X. Or you can just crank through it manually. Not that hard. It's just tedious. That is all.